For this problem, we're doing 2.4, number 9 from Method 182. And it's about the surface area of a surface of revolution. And I wanted to reference what was in the book. It says let f of x be a non-negative smooth function over the interval from a to b. Then the surface area from the surface of revolution formed by revolving the graph of f of x about x-axis is given by, here's our formula. It's going to be the integral from a to b, 2 pi times f of x times the square root of 1 plus f prime of x squared dx. And this is what we're dealing with in this particular problem, number 9. So when I come down here to number 9, we have this curve, y equals 2 times the square root of x. And it's going to be from 2.2 to 4.5. And that's revolving around the x-axis. And there's the shape they give us. So they break this into two parts. The first one, what would the function be that's going to be integrated? And so let's go ahead and look at this in a few little pieces. So the formula that we had from above is the integral from a to b, and we know what our a is in this case, is 2.2, and our b is 4.5, of 2 pi times f of x times the square root of 1 plus f prime of x dx. So what is our f prime of, and I'm sorry there's the confusion that they call it f of x, maybe they should call it g of x or h of x down here in the assignment part. But our function is 2 times the square root of x. I'm going to say y prime is 2 times, let's say y equals 2 times x to the 1/2. Helps me to see it that way a little better. So bring that power down 1/2 times x to the negative 1/2. So I just get 1 times x to the negative 1/2, which is 1 over the square root of x. Now, that helps us put together our formula, which would be this integral from 2.2 to 4.5 of 2 pi times the original function, which is 2 times the square root of x times 1 plus, and our f prime of x is 1 over the square root of x dx. Oh, sorry, this part is squared. So if we clean that up a little bit, we would have the integral from 2.2 to 4.5 of 4 pi. Now, what's interesting is this square root of x couldn't come inside and just be an x, because this is, oh, this is to the 1/2 power. I forgot about that. Yeah, to the 1/2 power. So we have that 4 pi from 2 pi times 2. Let me just do this. Call that square root of x. So 4 pi times what? We have the square root of x, and that's from this x, times 1 plus 1 over x dx. So we have this integral from 2.2 to 4.5 of 4 pi times the square root of x plus x over x is just 1. And they have a weird answer here in the book, or the homework program. Get a little shorter, dx. They, for some reason, call this 1 2.2 squared over 4, but they should take it as 1. So this is the formula I would have come up with for the answer to the first part, which is down here. That's what they're asking for, of what this would be. So now the next part is to integrate this. And I think it's easiest to do u substitution. If we said u equals x plus 1, our du is going to be just dx. So we'd have this integral, and I'll just change my limits of integration. Since it's in terms of u, I can add 1 to both parts of those. 3.2 to 4.5. You wouldn't have to change the limits of integration if you're going to go back to the x value in the substitution, though. So put the 4 pi here. Then I have the square root of u du. So that's going to be 4 pi. Oh, and there's, I just saw my mistake. We added 1 to this. It should be 5.5. So 4 pi times u to the 3 halves over 3 halves from 3.2 to 5.5. And we're going to have 4 pi times 2/3 times what? 5.5 to the 3 halves minus 3.2 to the 3 halves. And from that we get 60.10335319. Hope that helps.